Let's take a look at reference angles. A reference angle by definition is the acute angle formed between the terminal side of the angle and the x-axis. So basically, in order to find that reference angle, you're going to need to add or subtract the angle to 180 or from 180 to 360 or from 360. And so the reference angle, key things, it's an acute angle between the terminal side and x-axis. Okay, so we're looking for an acute angle. So if you get anything that's more than 90 degrees, you do not have an acute angle. Okay, so you have to make sure that when we're talking about reference angles, we're all talking about having acute angles. So if you're kind of looking at this, the big idea is that we kind of want to look at this in terms of different quadrants. So if I'm in quadrant 1, okay, so this is quadrant 1 here. If I'm in quadrant 1, the reference angle is just whatever the angle is, because I'm starting at the x-axis, and I'm going up, and any angle that I make in quadrant 1 is going to be an acute angle. Okay, so the reference angle in quadrant 1 is whatever the angle is. And so we're not going to go over that one, but you should know that they do exist in quadrant number 1. In quadrant number 2, here's the reference angle, the angle from the terminal side of our angle to the x-axis. Well, that means that this over here is our angle. Let's call our angle theta. And so in this little tiny spot here, this kind of this reference angle area, we're going to call that theta prime. Okay, so we're going to add to our reference angle definition here, and we're going to label it theta prime. Okay, with theta with the slash on it. And so that's my acute angle, is that theta prime, my reference angle. Well, if I look at this, my reference angle is completing that 180 degrees. Okay, if I combined my original angle plus my reference angle, it combines to make 180 degrees. So if I were to take 180 degrees and subtract out my angle, I would end up with my reference angle. That's exactly what needs to happen. I'm going to take 180 minus my angle that I'm given. Okay, and so in terms of degrees, that's going to give me my reference angle, theta prime. Okay, in terms of radians, what that looks like is 180 is pi minus my theta, as long as it's in radians, gives me my reference angle. So then I move on to quadrant number 3. So this is in quadrant 3 down here. Here's my angle. It goes like this. That's my theta. Okay, my reference angle is the angle that's this little tiny part right here. Okay, that's my theta prime. It's my reference angle. So again, if you look at that in terms of 180 degrees, that angle is actually going to be 180 plus some other portion. That portion is the reference angle. And so if I take this angle that I have, so I can take 180 or my angle and subtract 180 from it, and that will give me my reference angle. So if I let me try to explain that a little bit better. If I take this whole angle and I subtract out this part, okay, if I were to subtract out that part, then I have my reference angle. Well, that part is 180 degrees, so I'm going to take my theta, my angle, and subtract out 180 degrees, and that's going to give me theta prime. In terms of radians, I'm going to subtract out pi, and that's going to give me my reference angle. Okay, so my reference angle in quadrant number 2 is 180 minus whatever the angle is. In quadrant number 3, I'm taking the angle and I'm subtracting 180 in order to find out what that reference angle is. Okay. This is always going to end up being a positive thing. Okay, so even if I go in the negative direction, this reference angle is going to be a positive. So if you want to think about it as having absolute value around it, no matter what happens, we're going to end up looking at this angle in terms of positive degrees. So that might be something that you want to add to your reference angle definition as well. And then finally, in the fourth quadrant, here's the angle. Okay, so this is theta. If I look, my reference angle, it has nothing to do with that. It's this little tiny part right here. This is my reference angle, theta prime. Okay, so my reference angle in this problem is actually completing the 360 degrees. So if I take all the way around the circle and I subtract out, again, if I subtract out this part, if I subtract out that part, I end up with just my reference angle. So I'm going to take in quadrant number 4, this is quadrant 4, quadrant 4. In quadrant 4, I'm going to take my reference angle is going to be equal to 360 degrees minus whatever the angle is. And again, in radians, 2 pi minus whatever my angle is going to give me my reference angle. So if I take all the way around the circle, subtract out the part that I don't want, I have the part that I do want, the reference angle. And so what's important about that, this whole idea is that it's going to give me an idea of how to create a triangle with these trig functions and be able to find an angle theta. And so determine the exact values of the 6 trig functions. Well, my 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. And I'm looking of the angle theta at the point -3, 3. Notice that I'm not at one of the points that are on the unit circle, so I'm not in the unit circle right now. Okay? You don't have to be in the unit circle to use these sines and cosines, these trig functions. Okay? And so I'm not in the unit circle because I've got -3, 3. That is not a point on the unit circle. The unit circle doesn't go that far. Okay? So I want to look at this. I'm at the point -3, 3. Well, that's still an ordered pair, so I can still throw this on and the axes here. I'm at the point -3, 3. Well, this value here is 3. I went up 3. This value here is -3, and I can find the third side of my triangle by using the Pythagorean theorem. And I cannot just automatically assume that that's a 1. We are not in the unit circle. Okay? I don't know how many times I can say that. Not in the unit circle. We're not in the unit circle. And so that side is not, that hypotenuse is not 1. And so I need to find out what that hypotenuse is. So the hypotenuse is equal, hypotenuse squared is equal to 3 squared plus -3 squared. A squared equals b squared plus c squared. That's not true. A squared plus b squared is equal to c squared. And so I get h squared is equal to 9 plus 9. H squared is equal to 18, not 81. Take the square roots. When I take the square root, I get a plus and a minus. The square root of 18 breaks down into the square root of 9 times the square root of 2. And the square root of 9 is 3. I don't know why it keeps going to highlighter. 3 square root of 2. plus or minus 3 square roots of 2. And so this side over here is 3 square roots of 2. Okay, I have the option of using the positive or the negative. The negative doesn't make sense in this situation because it is a distance on a hypotenuse. And so I've got the values of everything that I need here. I can go through and do the sines and cosines. Well, the sine value, it is that 3 over the hypotenuse, but if I'm using the hypotenuse as 3 square roots of 2, then a couple things reduce here, and I need a little bit more space. I don't want to move that. I want to move this. Move. Okay. So I need a little bit more space to do this. These two reduce. So I get 1 over the square root of 2. I need to multiply by the square root of 2 over 2. Square root of 2 over the square root of 2, which gives me the square root of 2 over 2 reduced. The cosine, again, here's my angle. So I had opposite over a hypotenuse, and now I've got adjacent over hypotenuse, which is negative 3 over 3 square roots of 2. Well, because I know that math is all about patterns, the same exact problem that I just did, I'm going to do all the work, and I'm going to get square root of 2 over 2, but there's a negative in front, so this is negative square root of 2 over 2. And the tangent is opposite over adjacent, so that's 3 over negative 3, which reduces to negative 1. Cosecant is the inverse of this, so I've got 3 square root of 2 over 3, which the 3 is reduced, and I just get a square root of 2. Secant, it's the same exact thing, except that there was a negative there. Cotangent, well, if I flip over negative 1, I still get a negative 1. So we're kind of taking a look at each one of these. The first one was in an XY coordinate pair. The second one is giving us some information about secant. Well, secant is 1 over cosine. And so I've got secant is equal to negative 2. Well, I want to look at that in terms of a fraction so that I can create a triangle about this. So I've got a secant is negative 2 over 1. Well, that kind of leads me to believe that I might be possibly looking in the unit circle, but I can't be sure. So I'm going to assume that I'm not in the unit circle right now. So if I've got secant, that's 1 over cosine. Cosine equals the adjacent over hypotenuse. And so secant is going to be hypotenuse over adjacent. And so the hypotenuse of this is negative 2. Well, that doesn't make sense because the hypotenuse has got to be a positive distance. Okay, the negative part comes from moving left and right or up and down. And so when I say that I've got a secant equals negative 2 over 1, that actually means that the negative should go down with the 1. And so the adjacent is negative 1. So I go left 1, and then the hypotenuse is 2. So I've got this point right here with a distance here of 2. This is 1. The distance here of 2. And so I end up with this type of a situation. I end up with my distance across here, if I put this on an x-axis, to be negative 1. My hypotenuse is 2. But my hypotenuse doesn't necessarily say if it's going up or if it's going down. We would assume that it's going to go up, just because that's the way that we like to make triangles. But it doesn't say that. It just says that it's equal to 2. Okay, and so I can't make that assumption, which is why I have this last part here. Sine is greater than 0. And so when I look at my value for sine, which is this opposite side, over here, in both of these triangles, it's this opposite side. If I look opposite this angle, my question is, which one of those has a sign that's positive or greater than 0? And it's not this one. This one's going to have a negative. It's going in the negative y direction. Okay, and so my triangle actually looks like the one that's on top of this figure. So I'm just going to erase a little bit here, and then we'll take a look just at that triangle. And so when I look just at this triangle, I've got a side here of -1. I've got a hypotenuse of 2 because that was all the information from the secant. And then I have to find that opposite side. I have to find that distance in order for me to make my 6 trig functions. And so the way that I do that is the Pythagorean theorem. So I've got 2 squared is equal to -1 squared plus b squared. So I've got 4 is equal to 1 plus b squared. Subtract 1 from both sides. Take the square root, and b is equal to the square root of 3. Again, I get a plus and a minus because I created that square root, but I'm looking at sign being positive, which means that this has to be a positive square root of 3 instead of a negative square root of 3. If it was the -1, my triangle would have been upside down in the other direction. And so now I'm going to look at the 6 trig function. Sine is the opposite over the hypotenuse, so that's the square root of 3 over 2. That reminds me of what the things that are on my unit circle. So again, it seems like I'm probably in my unit circle. So you could find the place where the secant is equal to -2. You could find the place that the sine is equal to square root of 3 over 2 and a triangle that looks like this in your unit circle, and you could use that. Okay? You could use it for sine and cosine. You didn't have to, but you could. Okay? This then would look like this. Here's my unit circle. Okay, in my unit circle, I've got something that's in the second quadrant here. Okay, all of this stuff needs to start kind of meshing and coming together when we start talking about this. So I've got my triangle. The cosine is adjacent over hypotenuse, so that's -1 over 2. And tangent, if you are using your unit circle, you have this already. If you don't, then you're doing the opposite over adjacent, so that's square root of 3 over -1, which is negative square root of 3. The cosecant then is flip over the sign, so I've got 2 over the square root of 3. I can't leave it that way, so I rationalize the denominator, and I get 2 square roots of 3 over 3. The secant, well, they already gave us the secant, but it's also the reciprocal of the cosine. And then cotangent is -1 over square root of 3, the reciprocal of tangent. You can't leave it that way, so I rationalize the denominator, and I get negative square root of 3 over 3. And finally, example 3, find 2 solutions of the equation where tangent is equal to 1. I want to give my degrees, answer in degrees, and my answer in radians. And so I'm looking at where tangent is equal to 1. I can use my unit circle for this. So where tangent is equal to 1, I'm looking for a place that I have the same y value and the same x value. And so I can give 2 solutions for that. So I go back to my unit circle, and this one's already kind of used, but we could still use it. I'm looking for a place where I end up with the same x and same y value. Well, the nice thing about this is that your eye is probably drawn right to it because of all the work that we did from the last time here. But if I look at this, here's a place where this is exactly the same. Okay, the y values are the same, so I've got 45 degrees and pi over 4 as the place that I want that to happen. So this is 45 degrees and pi over 4. There's one answer, okay, in both degrees and radians. My other answer, where it's the same, is down here at negative square root of 2 over 2 and negative square root of 2 over 2, so 5 pi over 4 and 225 degrees. So 225 degrees and 5 pi over 4. There are a lot of other ways that you could do that. Your calculator probably is going to be one of them. You could do tangent inverse on your calculator. And so you could do the tangent inverse of 1. We'll look at where that came from, but that's something you could do on your calculator. If you're in radians, you're not going to get the pi value, you're going to get a decimal value, so you should be in degrees. And then when I'm looking at cotangent is equal to negative square root of 3. So that's the place where I've got an x over y that equals negative square root of 3 over 3. And so if I go to the unit circle, we filled in a few of these places before with tangents. So we've got a couple tangents here. These are not negatives, but they're positives. And so I want to look at these in terms of them being cotangents. Well, if I were to make this a cotangent, I would flip it over and I would get the square root of 3 over 3 after I rationalize the denominator. Okay, so that one is the one that I'm looking for. And so then I look at the next one, and if I were to rationalize this, I end up with just a square root of 3. And so my cotangent, I'm looking for ordered pairs that look like this, but they give me negatives. I need a negative in them. Well, that other ordered pair is over here, so we get 5 pi over 6 and 150. And then I'm looking for that same ordered pair with a negative, and the other one's over here at 11 pi over 6 and 330. And so when you take a look at those, you end up with cotangent being negative square root of 3 at these different places. That's going to finish off our information about reference angles. It's also going to kind of wrap up the beginning section of trigonometry here, being able to go back and forth between the unit circle, back and forth between radians and degrees, and then the next portion of this is how do we graph what this ends up looking like.